Okay, hello everyone, and welcome to today's webinar hosted by Women in Localization in partnership with one of our 2025 global sponsors, Smartling. Just a few housekeeping items before we begin. So today's call is being recorded, and the recording will be available to you at via our member portal if you're a Women in Localization member. If you're not familiar with Women in Localization, we're an inclusive organization with our mission is to foster a global community for the advancement of women in the localization industry. And we welcome as a member anyone in the localization industry who is committed to supporting our mission. So if you're not already a member, it's really easy to become one. You can get started on our website at womeninlocalization.com. Now, if you have any question during the presentation, please use the Q&A feature found in the menu bar below at the bottom of your screen. Today's workshop is all about benchmarking and learning how to choose the best fit AI model for you and your goals. Today's panelists are Marina Sanchez-Toron and Olivia Norris, both joining us from Smartling. So I'm going to stop talking and welcome to the two of you, and it's my pleasure to hand it over to you.
Thank you so much. All right, well, good morning and good afternoon, everyone. Welcome to Benchmarking 101, the road to finding the best fit AI model for you. I'm Olivia. I'm a junior data scientist at Smartling, and I'll be presenting with Marina, who is a senior linguistic engineer. As I said, my name's Olivia. I'm actually new to the machine translation industry. I'm a recent graduate from UC Santa Barbara with a Bachelor of Science in Physics and Statistics and Data Science, and my research interests are statistical analysis of translation quality, AI implementation in translation, and of course, what I'll be sharing with you today, which is benchmarking large language models. And now, Marina, if you want to introduce yourself.
Thank you, Olivia. So yeah, I've been working in a way or another in the language industry for over 20 years, almost going on 25 now. I work as a translator, computational linguist, data analyst, language analyst. I have an MSc in machine translation from Manchester and a PhD in translation studies from Auckland. And my research interests are widely translation quality and AI technologies in translation workflows. So yeah, very happy to be here.
All right, we're going to start off with a quick introduction section. We're going to talk a little bit about the large language model market, why it's important to benchmark, take a look at the large language model landscape, and then we're going to go over a roadmap to benchmarking and talk about our agenda for the workshop today. So starting off with the large language model market, here's a chart of the large language model market by year from 2020 up to 2024, as well as the projected market up and through 2030. As you can see, it's growing exponentially, so it's taking over almost every industry. But the thing that I like about this chart is that it actually breaks it up by industry. And if you look, you can see that language translation is fourth on the list. So it's a very exciting time for the localization industry. Now on to why it is important to benchmark. As I said in the last slide, large language models are taking over. Whether you like it or not, I think it is time to hop on that train because everyone else is. Now why it's important to benchmark your content specifically, because large language model translation quality varies across domain, language, and error category. So even though there might be a best model for translation, that doesn't mean that it's the best for a specific domain or language. On an even smaller scale, there might be benchmarking available to you. For example, Smartling does benchmarking once or twice a year that focuses on domain and language and the best large language model translator for each of those, but that doesn't necessarily equal your reality. Your specific content type, tone, and brand style might differ from that which was used for the testing. Additionally, you get control that you wouldn't otherwise have if you hadn't done your own benchmarking. You get to factor in things like speed and cost. You get to determine how fast you need your translations done, what quantity the large language model can take, and the cost per token that you are comfortable with. And last but certainly not least, new large language models are constantly being released. And so it's a lot easier when you have your own benchmarking data to get a quick benchmark when these new models come out. Now moving on to the large language model landscape. On the right-hand side is a little plot of all of the large language models as of March of 2024. So this is obviously super outdated, and there are probably hundreds more by now in 2025. But this is just to give you an idea of how overwhelming the large language model market can be. So over on the left-hand side, I gave you a little list of the frontier AI models and the highlights to help you decide which ones you decide that you want to benchmark on. For Smartling, when we're benchmarking, we tend to focus on the GPT family, the Claude family, the Gemini family, as well as Mistral and Llama. Now I'm going to give you a little roadmap to benchmarking, and this is kind of just going to be an overview of everything we're going to teach you how to do today. So you're going to start off with a really big data set of all of your sources and all of your translations that were likely translated by linguists for your company. And then the first thing that you are going to want to do is clean your data, and I'm going to outline how to do that in a later slide. And then there are two different routes that you can take. Either way, you have to split your data. If you're using a fine-tuned large language model, then you're going to have to split your data into the training set, validation set, and the test set. If you are not using a fine-tuned model, then you will split into your test set, as well as some examples that you're going to feed the large language models. Then if you're using a fine-tuned model, of course, the next step is to fine-tune that model to train your engine. And whether or not you're using a fine-tuned model, the next step is going to be to translate the test set through all of the models that you want to benchmark. From there, you will have your source strings, your reference translation strings, as well as the translations of all of the models that you want to benchmark. And the next step is to turn that into numeric data by calculating the metrics, because we can work with numeric data to get meaningful results. Then Marina is going to talk about human evaluations, how to decide which strings you would want to run through human evaluations when automatic metrics are not sufficient. Whether or not you decide to look at human evaluation or not, the next step is going to be to visualize and analyze your results so that you can ultimately determine the best model for you. So I know it looks like a lot right now, but hopefully by the end of this workshop, you feel really confident tackling this roadmap. So our agenda today, of course, we did the introduction section, and then we're going to get into data set creation, and then we're going to talk about statistical analysis for after you have run your translations, and then Marina's going to take over and talk about human evaluation. So starting off with data set creation, we're going to talk about cleaning the data, splitting your data into your training, validation, and test sets if you are doing a fine-tuned large language model. And then we're going to focus on the set that requires the most focus for benchmarking, which is going to be your test set. We're going to talk about requirements for a test set. Then we're going to get into random sampling, and I'm going to give you a little note on consistency. Starting off with cleaning the data, you have to remember that the data that you are using, whether that be for training and validation or for testing and examples, needs to be up to your standards. The training and validation sets are going to train your fine-tuned large language model to translate how you would like. So make sure that the translations that you are feeding it are at the quality that you want it to be at. Additionally, the same goes for the test set. It is going to assess the performance. So make sure it is assessing the performance of good quality translations. So I'm going to give you a little list of the things that we like to clean up, that we like to remove from our data sets. And that includes the sets for the training, validation, test, as well as any examples. So the first thing, of course, is objective linguistic errors. If a translation is incorrect or a source is incorrect, then of course you want to get rid of that translation unit. An example of this is "she go to the store yesterday." Of course, that is just not grammatically correct, so that is something that should be removed. And a quick little note for all of these things that I'm about to list to you, it applies to both the source and the translation. If it's in both the source and the translation, or the source or the translation, you're going to want to get rid of those translation units. Next is noisy translations. So as you can see, this example includes multiple languages, some random symbols, as well as a tag that is not formatted as a tag. So things like this, you're going to either want to omit completely, or you're going to want to split up. If your preferences specifically are not met, you're also going to want to get rid of those. An example of this is if you have any translations that don't adhere to a style guide you might have. Or for example, if you have a glossary, you might have terms that you don't want translated. So of course, do not feed the large language model any terms, any references where that do not translate glossary term is translated. Any unnatural sounding translations. So although a translation might be technically correct, that doesn't always mean that it is a good translation unit. An example of this in English is "please confirm the reception of this message" instead of "please confirm you have received this message." Again, this is just about reaching the quality of translation that you want. Something else that we try to avoid is any technical issues. These are typically with tags, spaces, placeholders, punctuation, and things like that. An example is mismatching tags. Of course, there should be the same number of tags in the source and the translation, same with placeholders and things like that. And last but not least is duplicates and inconsistencies. Both of these reference multiple of the same source string. So if the same source string occurs multiple times and it has the same translation every time, then we call that duplicates. You're going to want to get rid of these, particularly for your test set, because it will create bias when you are extracting the mean metric for your test set. If that translation did well and it was duplicated, then you would get too high of a score on your test set. And if it did poorly, vice versa, you would get too low of a score on your test set. Inconsistencies is where there is the same source but different translations each time. If that's in the training set, of course, it will confuse your fine-tuned model about how it wants that string translated. And if it's in your test set, then you will get points deducted one way or the other. All right, so at this point, you should have a large clean data set that you are ready to split. So the training, validation, and test sets is if you are performing your benchmarking on any fine-tuned large language models. So I'm going to go over the purpose of each of these subsets of your data set and how large they should be. Starting off with the training set, this is going to be 80 to 90% of your total data set. And when the model is training, the training set serves to teach the model patterns, mappings, and preferences. It will do exactly what you would expect it to. It will train the model based on your data, and it will end up outputting a trained model. While it is all still in the fine-tuning stage, this will then run through a validation set, which is 5 to 10% of your total data set. And I like to think of this as an internal test set. So it's like the model's test set. This validation set is used to evaluate the model and then tweak it based on the results. So it will change the hyperparameters and essentially send it back to the training set. And it will create this loop until the training set outputs the trained model that performs best on the validation set. And that is what gets returned to you as your fine-tuned model. Now you get to use a test set to assess this fine-tuned model. The test set, similarly to the validation set, is going to be 5 to 10% of your total data set. And the goal of this is to assess the model performance. It's very important to note that the test set does not play any role in the fine-tuning of the model itself. Therefore, it can serve as an unbiased benchmark of model quality. Now we're going to focus in on the test set. Here are some requirements for a test set so that you get statistically significant results. And I'm sure if any of you have taken statistics classes, there are 3 things that you are always taught for statistical significance of a sample, and that is independence, randomness, and size. And so this kind of follows along that similar methodology. Starting off with independence, translation units in the test set cannot be present in the training or validation set. Of course, that would give this fine-tuned model a leg up, and it would perform better than it would on new data coming in that it hasn't seen before because it knows exactly how to translate that data. Next is going to be size. We like to stick to exactly 2,500 translation units for statistical significance, but anything from 500 to 5,000 will still be statistically significant. We tend to do 2.5 because anything more than that doesn't really give us, doesn't level it out anymore, and we like to cut back to save on token cost. Next is representativeness, and what I mean by this is that your test set should represent the larger population that you want to extend your conclusions to. This is typically done via random sampling, which I'm going to outline in the next slide, and I want to make a quick little note here that you are absolutely allowed to focus in on specific use cases. For example, if you wanted to test how well different models perform at translating strings with tags and placeholders, then you can definitely make a test set with just tags and placeholders as long as it follows all of these other requirements. The only thing is that you cannot then extend that conclusion outside of the strings with tags and placeholders. So if it performs poorly, you can't say that it performs poorly at translating period. You can just say that that model performs poorly at translating strings with tags and placeholders. Next is going to be high quality. Of course, we outlined the cleaning methods on a previous slide. So just make sure that all of the content that you're putting in your test set is at the quality that you want your translations to be. Now we're going to talk a bit about random sampling, which I said is the most common way to get a representative sample of your population. There are so many different ways to do random sampling, and I encourage you to go look at them yourself in your free time if that's something that's of interest to you. But here are the top 4 that I tend to use the most when we're talking about translations. On the far left, you're going to see simple random sampling, which is what most of you probably think of when the term random sampling comes up. And this is where each translation unit has an equal chance of selection. It is plain and simple random. Now onto the more methodical ways of random sampling. We're going to look at cluster sampling, which is where you're going to split your population into representative clusters. What I mean by this is, for example, if all of your content that you were trying to assess the performance of, so your population has 2% of the translations with tags, then each cluster should have 2% of its translations with tags. And then you take a random selection of each of those clusters. Now for stratified sampling, it's kind of similar because it also splits into subgroups. However, it will split based on a subgroup type. So an example of this that we like to use is content type. So you would have a group for example UI, a group for marketing, a group for internal use, and then you take a random sample from each of those subgroups. Both cluster and stratified random sampling are ways to ensure that you represent the less common occurrences that would sometimes be overlooked by simple random sampling. And now on to systematic, which I would say I use the least for translations. It's an ordered random sampling method. So my most common use case is the length of the string. So you would order based on length and then take every kth translation unit. Now, I want to give a quick little note about consistency, and I would like to say that this is not necessarily a requirement. As long as you adhere to all of the test set requirements that I listed in the earlier slide, your results will be statistically significant, which means that you can compare things like the mean and the median to find your best performing model. However, when I'm doing benchmarking like this, I have learned that it is almost always best to use the same train and validation set, similar prompts and examples, and then by far the most important is the same test set. What this permits you to do is then look at the results on a string by string basis, rather than having different strings in your test set and then having to find similar ones or see if they are somewhere in the other test sets. You can just put them side by side and see how each model translated each string. All right, so at this point, you should have all of your sets, your train set, your validation set, your example set, and your test set, and you should have run all of your sources, your test set through all of the models that you want to benchmark. And so now you should have your source strings, your reference strings, and then all of your model translations. And we're going to go into analyzing those results. We're going to talk about common metrics, visualization, and then I'm going to do a quick demo with ChatGPT. So starting off with common metrics, in the top, you're going to see some textual scores. What this means is that they don't look at the meaning of the words themselves. They just look at the text. And on the bottom, you're going to see semantic scores, which means that they do take into account the meaning. This means that the scores on the top would not, synonyms would not score well, but on the bottom, they would. So starting off with blue, and the arrow next to each of these metrics represents whether higher or lower is better. So for blue, higher is better. It's on a scale of 0 to 100. And it uses n-gram precision and brevity penalty to calculate the score. And the threshold for a good translation tends to be greater than or equal to 40. And blue is a big industry standard score. And in the last bullet point across all of these metrics, I added either Python packages or repositories that you want to look at if you want to automate this through a Python script. Moving on to TER, or translation edit rate. Lower is going to be better. It's on a scale of 0 to 1. And this is calculated by looking at the edits made divided by the length of the string. And the threshold depends on which language group you are looking at. It's going to be less than or equal to 25% for Romance languages, but all the way up to 40% for low resource languages. From TER, you can also extract human parity. Higher is better, and it's on a scale of 0 to 100. And what this is going to tell you is the percentage of the translations that were at the quality of a human translator. This is determined by looking at the TER, and it's the percentage of the strings where the translation had a TER of about 0. We tend to use less than or equal to 5%, tends to be at the quality of a human translation. And then there's no Python package for this, but you could do a simple if-then sum over the TER. Now moving on to semantic scoring. Starting off with metric X, which is a little bit new to the game. Lower is better. It's on a scale of 0 to 25. And this is Google's Learned Translation Error Score with a threshold of less than or equal to 2. Now, COMET has been around a little bit longer. It is another learned semantic machine translation metric. Its scale is 0 to 1, and the threshold for a good translation is greater than or equal to 0.75. Now for BLERT, where higher is better, it's on a scale of -1 to 1, and it's a BERT-based human score predictor, so it tries to determine what a human evaluator would score the translation at. Now I know all of this, as well as all of the other metrics out there, can be very intimidating, and it's hard to know which ones to focus on. So for Smartling, we tend to put the most weight into TER. It tends to be the most reliable measure of how good a translation is. And then if you want to throw in a semantic score, we typically put the most weight in metric X, although it is a little bit of a black box. We don't exactly know how the score is calculated. So we like to look at TER and metric X, and if you want another score in there, like I said, blue is a big industry standard. So at this point, you should have turned all of your string translations into numbers, depending on which metric you decided to use. And now we're going to get into visualization and analysis. So with all of these numbers, some key performance statistical metrics that we like to look at are the mean and the average, which can typically pair with the confidence intervals. We look at the median, which we can also pair with the quartiles, and then we look at outliers. And in this context, outliers are typically indicative of hallucinations. If there are outliers that are performing far worse than all of the other translations in the dataset, that typically means that something went wrong. Now for using visual indicators in a meaningful way, here are some things that I like to include in my plots. Error bars are very useful. Like I said, I like to use confidence interval bars on mean plots. And then we also like to use the threshold lines. Like I told you in the last slide, talking about metrics, there are thresholds for good translations. And I like to visually include those in my plots to show where the line for a good translation is. I also like to use colors in a meaningful way, and this is, the most fun of them all, I would say. I like to make the different bars different colors if I'm using a bar chart, or different models, different colors, and things like that. If you want to get a bit more advanced with that, then with bar charts, you can do grouped bar charts, grouping by language group, for example. You can also do stacked bar charts, and I'll show you an example use case of that. Now, the most important question to ask when you are visualizing your data is, what do they want to see? And this is something that is very commonly overlooked. And when I refer to they, I mean whoever you are presenting to, whether that be just you, what do you want to see? What is the goal of this presentation? And then you need to cater to that goal with your visualization. What this often means is if you want to make it a simple or a complex plot, I tend to use simple graphs when I am presenting externally, and complex graphs when I am presenting to, say, the engineering team. And you can also ask if you want to do something like making the plot referential, and I'll show you an example of that on the next slide. So here's an example of a benchmarking that I did in summer of 2024. So this is very outdated. Do not hold any weight to the results in the plot. But I asked, what do they want to see? And I was presenting to my team, and what they wanted to see was the model performance with reference to the leading translator, which at the time was AutoML. So instead of just plotting the raw blue scores, I actually calculated the line by line how much percentage of blue AutoML outperformed, for example, AutoSelect, and then I averaged those and plotted those. Also, as you can see, I used confidence interval bars to show the variability of the data, and I used different colors for each of the models. Here is another example. This was an experiment that I did in converting translations from masculine to non-binary. And on the left-hand side is an overarching plot that shows the average across all of the languages for each of the models. And like I said, I like to use different colors for each of the models. And this is actually a stacked bar chart, which is nice. There were two different things that I wanted to show for each of the models, so I decided to stack them because one was always going to be higher than the other. It's going to be the semi-success rate and the total success rate. I'm not going to go into detail about what that means, but this is just a way that you can use stacked bar charts. Additionally, from there, you can break it down depending on what you want to look at. When we're actually doing implementation, of course, we don't just want to use the overall best model across the board for all languages. So something we could do is break it down by language. On the bottom right, you're going to see the model's performance for specifically Spanish. And then you can also break it down looking at a model and breaking it down by language. So on the top, you see Gemini Flash's performance per language. So visualization is really, in my opinion, the best part of the entire benchmarking process, and it's very rewarding to finally see your results. This will typically take you to the end of the benchmarking process, but I know it can be a little bit intimidating if you're not super confident in your coding skills or if you're not super confident in your statistical analysis knowledge. So we're going to do a quick little demo. And here is a sample data set that I used. It's completely manufactured, so don't look too closely. It has a source column, a reference column, and then a column for all of the models that I wanted to test. I kept these anonymous for the sake of this process, but of course you would typically put the model that you were testing, the actual name of it. And again, I just downloaded this as a CSV. And I'm doing this demo just to show you that analysis is not for just for data scientists anymore. It's for everyone. And here is a very simple example prompt that I'm going to feed to ChatGPT with the CSV that I showed you before of all of my translations. It takes in a CSV file with a source and reference column and any number of additional columns representing different translation models. And then it's going to output a plot for the mean and a plot for the median. And the plot for the mean should have confidence interval bars. It will also have a threshold bar, and each of the bars will be different colors. So I'm going to do that really quick. And of course, feel free to copy and paste. This should be available to you if you have data that is formatted similarly. So I'm not going to make you sit here because when I was testing it, it did take about 4 minutes, and I don't want to cut into Marina's time. But as you can see, here is the data set that I used, and then here is just a copy and pasted prompt. And as you can see, here are two beautiful plots that we had to put barely any work into. Here is the median, and here is the mean. So hopefully that makes you feel a little bit more confident about your ability to visualize the data and determine which one is best, which in this case is, of course, Model 3. All right, so that should take you to the end of the automated analysis portion, and I'm going to hand it over to Marina to talk a little bit about human evaluation.
Thank you, Olivia. Okay, so I'm gonna share my screen. Just 1 second. I'm having some issues here. What is it? Okay, found it. Sorry, I've been doing this for a long time and still, yeah, okay. Okay, no, this is not what you're supposed to do. I'm sorry. Okay. Do you see my slides now?
Yes.
Yes?
Yeah.
Okay, thank you. Right. Yeah, so I'm going to cover benchmarking, but from a human evaluation perspective. So there's these 4 key areas: the challenge of human evaluation itself, then choosing your evaluation sample, then choosing your evaluation approach, and finally some best practices to make your human evaluations more reliable. So I'm going to take approximately 15 minutes. So on the one hand, we've seen how Olivia has shown us how automatic metrics are super convenient, they're fast, they're cheap, and they give you very quickly comparisons, yeah? So I put a hypothetical scenario here where you run 4 models through some metric that I don't know which one is it, but the higher the better, let's say. So based on this scale here, you see model 1 scores 0.94, model 2 0.92, and so on. So it's clear here model 1 wins, right? But an automatic metric like this is not so great at telling you why model 1 is better, for example, or what specific errors each of the models make. Or even something like, do the lower scores in model 4, for example, 0.71, come from errors that matter to you, to your use case, or are they errors that you can live with? So this is where human evaluation comes in. Yeah? Human evaluation is usually considered a gold standard to get the best insights about translation quality, but it's not without challenges. So 2 of these challenges are that it takes a long time to conduct human evaluation, and it's also expensive. You have to pay people to do this evaluation, yeah? And we've seen how Olivia has shown us how you can run these metrics on massive data sets, but if eventually you want to know more and you want to send some of that data to humans, you cannot send every system output that you've evaluated automatically to do human evaluation because you have some cost and time constraints. So the key question I'm going to be covering today is how can you make the most of your human evaluation budget and get the best results after you run your automatic metrics. So I have 3 recommendations in order to do this. The first is choosing your evaluation sample strategically. Olivia has talked about random sampling. I'm just gonna go, okay, within that random sample, we may do some strategic sampling, yeah? So the first technique to do this is focus on output diversity when it comes to select which items you're going to send for human evaluation. By items, I mean sentences, paragraphs, documents. I'm illustrating the example here with sentences, but you can expand that. This concrete example, for example, imagine you're evaluating the translation, sorry, of 5 new suspects arrested in connection with Louvre robbery. You have run the source text through 4 systems, and you see that you get Model 1, Model 3, and Model 4. They produce identical translations, and Model 2 produces an almost identical translation. Yeah? So this would be a low value item for human evaluation, because why would you spend time and money having a human look at 4 nearly identical translations? Because this particular item tells you almost nothing about which model is better. Now, if you put this in contrast with this example, can I learn to be cool even though I don't even know how to pronounce it, garrulous, furry, and wear no-show socks? So when you translate this sentence with your 4 systems, you get a wide variety of translations. So I just highlighted some words that are different, but you got other differences there. Model 1 says charlatan. Model 2 adds some explanatory text in brackets. Guay o genial. Models 2 and 3 use feminine forms, so they are quite different translations. Yeah, this would be a high value item because each model produces very different translation, but a human can tell you in detail, can give you rich feedback about what the nature of those differences are and which system can be better for your use case. So in summary, this strategy is about prioritizing examples where models produce diverse outputs. Now, technique number 2 is similar, but it's about prioritizing items where you see there's a metric variance. So focus on examples where your automatic metrics show disagreement among models. This sentence, for example, I dressed up as a superhero for Halloween. When you look at the Comet Q scores, for example, of 4 different translations, you see they are quite clustered together. They range from 0.86 to 0.89. So all models are performing similarly according to Comet QE. That's why this is a low value item. The automatic metric is already telling you these models are roughly equivalent on this example. Now, on the other end, you have this sentence. Strapped for cash while Francis Ford Coppola is flogging his watches. So if you look at the Comet Q scores, they range from 0.69 at the bottom to 0.81. So that's a 0.12 difference. You can see there's a clear quality variance here. So in summary, this strategy is to use automatic metrics as a filter, find examples where metrics show high variance, and invest your human evaluation budget there to understand what's going on. By using this strategy, you can often reduce the number of examples you need to evaluate by 30% or more, so you will be saving some money there. And by the way, this is based on this paper that I put here, research by Suhar et al. It's a recent paper a few months ago, so I encourage you to take a look at it if you want to learn a bit more about it. Now, another piece of advice for making your human evaluation more reliable is choosing your evaluation approach. So you know what to send for human evaluation, but you need to decide how to evaluate it. So there's a wide spectrum of approaches, and the right choice depends on your goals and resources. So on the simpler end, let's say you can opt for a simple scoring approach. This may be asking evaluators to rate outputs on a 1 to 5 scale, or doing pairwise preference judgments, where evaluators simply say which of two outputs is better. So the advantages here are clear. It's fast and easier than other approaches. It costs less than other approaches, and you need less training time as well to get evaluators up to speed and complete the evaluation. Downsides, these scores are not very interpretable, and you get no error breakdown. Yeah? So what does a 3 or a 4 or a 5 tell you? Or a 5 might tell you that it's a perfect one, yeah, but it may not be so easy to differentiate 4 from 3, for example. So on the other end, I'm sure many of you here are familiar with MQM, but you have comprehensive approaches like full MQM error analysis or derivation simplifications of MQM. MQM stands for multidimensional quality metrics, in case someone doesn't know, but with the MQM framework, evaluators identify and categorize every error. So you can have mistranslations, omissions, and so on. They also assign a severity of the error, minor, major, critical, and maybe an error span as well. Where does the error start and where it ends? Downsides are that it takes a long time compared to other approaches. It is more expensive, and it requires more training for your evaluators. So when it comes to choosing, you should ask yourself at least 2 questions. One is, why do I need this evaluation? Do I need it to improve my own models, or do I need it to choose between 2 models? So if you're fine-tuning your model, like Olivia was saying before, you might need to have some detailed error analysis to know what to fix. If you're just choosing an off-the-shelf model, for example, maybe scoring them with a simple scoring approach is enough. And of course, your budget also should be taken into consideration. Now, a final recommendation is implement best practices for evaluation. So any sort of human evaluation that you conduct or organize is more reliable and valuable, whatever approach you choose. So there's 4 best practices here that I listed. So first one is very important to use clear guidelines, clear evaluation guidelines. They need to be detailed, but not overwhelming, and they need to be unambiguous. It's not easy. So you shouldn't assume evaluators will intuitively or naturally understand what you mean when you say high quality or low quality, or when you use words like accuracy or fluency. You need to define all those things. Second is include concrete examples in your guidelines. So show evaluators what a score of 5 looks like versus a score of 3 if you're using simple scoring, or show them examples, actual examples of mistranslations versus an idiomatic if using a full evaluation, sorry. Also define edge cases explicitly. Edge cases are usually not that edge. They're usually more common than you think at the beginning. So things like what to do if the source text itself contains errors. Evaluators should know about that, what to do. And last point may be obvious as well, but making these guidelines available during evaluation and in the most convenient way possible. For example, directly on the evaluation interface or linked from the evaluation interface is important. You don't want to have your evaluators switching between screens or tabs too often. No? Second point, train your evaluators. So another assumption that you shouldn't have is providing guidelines is enough. Ideally, you should plan for some sort of interactive training. Interactive in that evaluators do something and they receive something else. So for example, give them practice examples, have them make judgments, and give them feedback on those judgments. Discuss whatever disagreements they have, different evaluators they have, and make sure everyone understands the guidelines in the same way. This is not easy. One recommendation is only begin actual evaluation after you verify that evaluators have a common understanding of the task. So it may feel like it's slowing you down at the beginning, but it saves time and money in the long run to prepare this well. Third, best practice is do a pilot test. So before launching your full evaluation, run a small scale pilot with representative data that you're going to be evaluating in your main evaluation. So maybe 30 to 50 examples per person, and take a look at the pilot results carefully. You should be able to answer questions like, are evaluators able to make consistent judgments? Are there guidelines that confuse them? Did any edge cases come up that you hadn't anticipated? And based on that, refine your guidelines. Often, you will discover that things you thought were clear, and maybe you were, I'm sure some of you already have experience with this. So I hope I'm not preaching to the choir here, but you'll see that something you thought was clear actually wasn't. There's an important distinction you hadn't included. Huh? And one final thing is be prepared to do this continuously. Don't think guideline refinement is something you do at the beginning, a one-off effort, because you will need to do this hopefully less frequently with time, but this is something that will need to be addressed as long as the evaluation lasts. Huh? And final best practice is implement some sort of quality control. So you need it throughout your evaluation process. You can measure agreement or correlation with ground truth and or other evaluators. If you have multiple evaluators, you need to have an answer in the form of a number that says, are they making similar judgments on the same examples? You can use correlation metrics or, agreement coefficient, sorry. So if agreement is very low, maybe you have a problem with either your guidelines or your training. If you only have one evaluator, which is usually when you have a low budget, you should at least measure agreement or correlation with a ground truth, especially in the beginning of the project. So a ground truth is a known correct answer. So this ground truth helps you check whether your evaluators are identifying them correctly. Yeah? And it also validates that your evaluation is measuring what you want it to measure. So finally, you can use quality control items strategically. These are examples where you already know the answer, and you can put them in between the evaluation to check if evaluators are staying consistent and attentive. So I'm going to wrap this up with the key takeaways of the human part of this presentation. So human evaluation is essential in some high stakes cases, but it's expensive. So one recommendation is to make it count by being strategic about how you select the sample that you send for a human evaluation. I listed 2 recommendations, but there's more literature with more options, but these recommendations are focusing on examples with high output diversity and a high metric variance. Second conclusion is choose an evaluation approach that matches your goals and budget. And third, follow best practices, clear guidelines, train evaluators, pilot testing, and ongoing quality control. So that's it for me. I want to say thank you for listening, and I don't know if there's any questions.
Yeah, we have a couple. One, did you, Emma or someone else want to?
Okay. Let me see.
Yeah, we have some questions in the Q&A. I think Olivia has already answered some of them. So Lucia asked, how do you identify the low value items in terms of similar output based on the scores of an automated metric?
Okay, so you can use an automatic metric that is referenceless. like a quality estimation metric, for example, Comet QE. Blue, some implementations of Comet, I think some implementations of metric X as well. You need to have a ground truth. So you need to have some good translation to compare your translations against. But when there's some references metrics that they're not really called evaluation metrics, they're more like quality estimation. So if you only have a source text, you can assign a score to that source text based on the translations, machine translations that you get, but not against any comparison. So if you are sending one document to 5 or 10 systems and you get very different average Comet QE scores, for example, for those documents, that might be a high value item because something is different in one of those documents, and that will help you differentiate the systems. If you're sending 5 documents and you get a very similar score across 5 systems, that would be a low value item. I hope that answered your question, Lucia. Okay, there's another question. Okay, for simple scoring, which Likert score values would you recommend, 1 to 5? I wouldn't recommend Likert scores at all, to be honest. But if I had to recommend them, I think, I mean, I've worked with those in the past, and what you eventually get is a bunch of 3s, which is not very informative. So I would like to try something like 1.7, maybe, with clear definitions of 1.7 is. But yeah, I'm not sure. I'm not too fond of Likert scales, but usually it's 5.5 or 7 point that you get. Yeah.
I can answer the next one from Francis. Said our data set would likely be human edited MT output. Is that appropriate, or does it have to be pure human translation? Would using MTPE allow us to do a fair comparison to a suite of MT tools that included the original MT or any other considerations? Yeah, so the reference, I'm guessing you're talking about using what's used as your reference translation. That's up to you. I would say as long as it's been through a human. So we do oftentimes use something that's run through post-editing and been edited by a linguist, or we use the published translation that's been looked over by a human linguist as the reference. It's up to you. This just needs to be your true translation that you want to perform your benchmarking against. So it needs to be what you want the content translated like. I hope that answers your question. Okay. What's your approach to selecting benchmarking participants who are curious and positive about large language models and new technology in general? Are you talking about how Smartling chooses what clients' content to benchmark on, or Marina, do you think that's what the question is?
I kind of understand like human evaluators, benchmarking participants, human evaluators. That's what I'm understanding from this. But let me know right there if I'm fully misunderstanding this. At Smartling, the evaluators are trained linguists, trained translators with, I mean, I think English doesn't distinguish much between linguists and translators, but Spanish does. So they're usually translators with a lot of experience, and and they have experience with machine translation. So I would say everyone that works with Smartling, and maybe most of the large LSP AI translation companies, are positive about LLMs and new technologies. So yeah, usually mostly they have a translator profile and a lot of experience in translation and evaluation. Yeah. I hope that answered your question. There's another question, Olivia, right at the bottom. I don't know if you want to take that one by Francis.
Sorry, which one?
If you scroll down.
Oh. Do you find that there is a plateauing in machine translation quality, as has been reported in large language models in general? For large language models, I would say no. I think that they are actually getting a lot better every day. We're doing benchmarking pretty often, so the quality of the translations is getting better and better. And large language models are surpassing neural machine translations, which do seem to be plateauing a little bit. I don't know if that answers your question, but yeah, our benchmarking shows that they are getting better.
Olivia, I think the final question is for you as well.
How big are those data sets when running experiments? Our benchmarking, like I said, we tend to stick to the 2,500 translation units for a test set. And then we look at several different domains, and we tend to go across all of the big models that I listed at the beginning of this presentation. So there's a lot of runs, but the data set itself is typically 2,500 translation units per domain, per language.
Okay, I think we've answered all the questions we have on the Q&A. I don't think I'm missing anyone.
I think so. Yes. Someone asked,
there's
you
only one.
mentioned reference documents and materials.
Mm,
I don't
I'm not sure.
know who this question is for.
I'm not sure if the person who wrote this question, maybe they can explain a bit what I mean. I'm not sure if I mentioned this. Olivia, do you remember you mentioning
I
something?
think it might be in reference to another question. I'm not sure. Yeah, I mean, I referenced the reference trans. Okay.
I think that would be linked. Okay, I see now. Okay, I think I mentioned that if you are planning to run an evaluation, you should link your evaluation guidelines in the evaluation interface. I hope. I think that's what you're referring to. I haven't prepared any documents, any reference documents or materials to be linked, because I mean the only thing is that paper that I mentioned, but I think that's what I was referring to. Yeah.
And then someone asked
Final.
how we keep up to date, if there's any podcasts we like or papers from conferences we usually go to. I'm guessing you're talking about when new large language models are released or new versions come out. Luckily, we're very fortunate that our team tends to stay on top of the research papers, and also Smartling as a company typically gets a little bit of a heads up from the providers about when a new model is going to come out. But Marina, I feel like you're the person to go to for where you look for your research papers and if you listen to podcasts.
So one suggestion I have is curate. If you have LinkedIn, a LinkedIn profile, curate it so interesting things show on your feed. You know, LinkedIn can be some sort of kind of there's a lot of noise there, but if you follow the people who are doing research, you will get interesting things. I usually follow researchers I follow researchers from Meta, from Unbubble, former Unbubble, from YouTube, Google, and that sort of creates a network of researchers. So I would encourage you to use LinkedIn as a sort of starting point to curate a feed where you will see all these cool papers pop up. Yeah.
I got a question. When you benchmark different AI systems, do you first train them with your training and validation sets, or do you go straight to testing? So that entirely depends on what you are benchmarking. If you're benchmarking fine-tuned large language models, then those require the training and validation data sets. But when we're doing our large-scale benchmarking, we just use examples and an extensive prompt, and then we go straight to the testing with the test set. But it's up to you if you want to look at fine-tuned large language models or just, like Marina said, off the shelf large language models. And then I got a question, why do you prefer TER over semantic evaluation models? This is just based on what I have seen. TER is very reliable because it just directly compares to what we know to be the best translation. Whereas the semantic evaluation models are a little bit of a black box, particularly metric X, we find to be a little bit inconsistent, and we're not exactly sure why it gives the scores that it does. It also tends to overlook things like glossary terms, so it might score lower. Even the referential metric X model will score lower for a do not translate glossary term, whereas the TER would take that into account.
Awesome. I think we'll stop it at there. Thank you so much for everyone's participation and engaging in the conversation. Thank you, Marina and Olivia, for these insights. If you have any other questions, feel free to connect with Marina and Olivia on LinkedIn. And this recording will be published on our member portal as well for Women in Localization members. So thank you, everyone.
Thank you.
Thank you so much.